The main topic we want to discuss today is how the security is integrated into DevOps and continuous integration and continuous deployment or delivery. We want to demonstrate how to resolve the problem and how defense code products fit in the story. DevOps emerged as a set of practices that automates the processes between software development and IT teams. Adopting DevOps practices and implementing CI/CD allows organizations to meet customer and business demands faster or even release their product in a timely and effective manner. Ideally, CI/CD would allow for safe and perfectly functional products to go into the market quickly. However, security and smooth experience are often compromised for speed and cost. Since companies often try to meet business demand and beat competitors to the finish line, speed and efficiency are usually the keys here, and unfortunately, security and smooth functionality aren't. So, how can we make sure that security is taken into account in such a fast-paced atmosphere? Well, we must not sacrifice automation and speed for it. Two most effective methods of automating application security testing are static application security testing or Sast and dynamic application security testing or Dast. A static source code security analysis tool would try to find out how data flows through the application. Let's say from an input source like a form field on the website all the way down to a security sensitive sync point like a database call. By analyzing this flow, the tool checks if these security-sensitive syncs are safe and sanitized, and that's how a Sast tool finds vulnerabilities. So, instead of attacking the application from the outside, a Sast figures out the internal workings of the code base and tries to find vulnerabilities from within. Because of this, Sast doesn't require the application to be functional and running. Therefore, such solutions can greatly improve the security through automatization at various stages in the pipeline. Dast tests web applications and services by using mock attacks via HTTP, similar to what a hacker would do. This method is called Blackbox Testing. Simply, a Dast scanner doesn't need to have access to the code and the inner workings of the application. In fact, it automates what a hacker would do in a live application. Thus, when a vulnerability is found, it usually means that the vulnerability could be exploited. Often, a good Dast scanner will show evidence that the vulnerability is real by safely exploiting it, and will show you how you can fix the issue. This allows pen testers and developers to save time. However, Dast's biggest assets comes at a price. Dast scanners can only test a functioning application, meaning you can only scan with a Dast scanner once an application was successfully built. So what is the best approach? We say both. This flowchart represents a best case scenario of integrating application security in CI/CD pipeline. Defense code covers every item that can be seen here, which will be further discussed in the upcoming webinars. Today, we will focus on the first item that deals with pre-commit checks in integrated developing environments as well as ThunderScan web user interface. Performing scans using the ThunderScan web user interface provides developers with an easy way to share or view vulnerability results through centralized access and various reporting formats. The developers are able to upload source code for analysis or scan repository branches. This is a login screen to the ThunderScan SaaS solution. After proceeding with the login, we are presented with a dashboard that currently has several finished scans listed. By clicking on the New Scan button, we are presented with the configuration of a new scan. First, we need to choose a language that will be analyzed. As you can see, we have a wide selection of supported languages. For each of the supported languages, you can review the vulnerability types covered by the analysis. Any of the listed vulnerability types can be excluded from the scan. For example, we can exclude some of the low-risk vulnerabilities such as error messages, information exposure, or log forging. And these will not be shown in the results or the generated reports. Further on, we can choose to configure tracked input variables, which refer to functions or properties that take or represent the user input coming from a source, such as HTTP request, file content, command line parameters, etc. Thunderscan supports several target types. These are uploads, which refer to zip archives of the target source code, local paths on the same server where Thunderscan is running, as well as Git, SVN, and Team Foundation server repositories. For this demo scan, I'm going to use a Git repository target. The remaining settings seen below can be used to fine-tune the scan by adjusting the scanning depth in terms of tracking the user input through function calls or variable copying, or defining new custom filters to avoid false positive results when Thunderscan comes across custom functions that filter or sanitize the user input in some manner. Custom rules can define signatures of sync functions that may exist in custom frameworks to produce more true positive results. Let's name our scan and start it. Following the started scan, we are now seeing a scan summary where the results will appear shortly as the scan progresses. From this view, you can choose to compare the scan to one of the previous scans, or you can immediately generate a report before reviewing the details. Reports are available in HTML, PDF, XML, and JSON formats, as well as several report types such as Defense Code Default, as well as compliance formats such as OWASP Top 10, SANS-CWE Top 25, NIST, and PCI DSS. As the scan is finished, we are going to proceed to the details of the scan. On the left side here, you can see a tree view that shows all the found vulnerability types for the scan. By opening any of the vulnerability types, we can review details of the individual vulnerabilities that were found. The details for each vulnerability show the following information. We have the vulnerability function that caused the vulnerability, a description that shows that that vulnerability can be abused to perform a SQL injection attack. We have the information that shows what the input variable is, that is, where the user input came from, the vulnerable project file, as well as vulnerability description and mitigation recommendations. We also have references to OWASP and CWE as well. For further inspection of the vulnerability, we can review the call stack of the vulnerability. This refers to the user input flow through function calls as well as variable copying. We can see that the user input started in text email text variable, which will immediately be highlighted in the source of the project. We can see that it was passed on to the get security question and answer function, as can also be seen in the function calls. We can see that it was used as the email variable in that function, and that variable was further on used to create a SQL query by concatenating to that string. Finally, the SQL variable was passed on to the SQL data adapter function, that caused the SQL injection vulnerability. This level of detail is available for every supported vulnerability type, as you can see. If you determine a vulnerability to be a false positive, you can mark it as such, and all the results marked as false positive can be excluded from future scans over the same source code base. That way, Thunderscan adapts to the source code the more scans are performed. To submit a ticket to one of the supported issue tracking systems, you can simply choose a project for Jira or Team Foundation server and submit a ticket for the issue type that is chosen. The ticket will contain all the information necessary to track down the vulnerability in the code. Now let's generate a report for this scan. We will choose HTML format of the defense code default type. As you can see, the report contains scan summary per vulnerability type. We have all the vulnerability groups that were found, as well as the number of findings in each group. By clicking on any of the vulnerability types, we get the same information that we saw in the web UI. So we have the vulnerability description, mitigation recommendations, references to OWASP and CWE, and for individual vulnerabilities, all the information necessary to track down the vulnerability in the code. So we have the exact project file, vulnerable function, as well as the function call stack and user input flow. Each function call stack item and user input flow item have project files, code lines, as well as the variable that the user input was passed on. Now, with other report formats, such as the JSON report, this provides a way for Thunderscan reports to be imported into other dashboards or parse the report in some other way. As you can see, the results are properly structured, fully with recommendations and vulnerability details. The same method applies to XML reports. Now, as the Thunderscan has a rich API that enables us and you to create various clients for it, other than command line clients, which we will discuss in one of the next webinars, IDE extensions are one of the most useful clients that we have. The question that often arises around the use of Sast tools is scaling. How well would a tool scale in a large organization that might perform thousands of scans per day? Thunderscan resolves that issue with the deployment of scanning agents. As a cross-platform solution, both Thunderscan and its agent can be deployed on any number of Docker containers, virtual machines with different operating systems, or even developer workstations. That kind of horizontal scaling would allow for hundreds of parallel scans across the organization, initiated from the web user interface, IDE integrations, API calls, and other. Thunderscan is a multi-user environment. That means that you are able to create new users, create user groups, assign those users to user groups which are separated by privileges. For example, one group of users cannot access the scans belonging to another group. You are also able to integrate the authentication into LDAP or Active Directory. So instead of creating users directly in the Thunderscan environment, you will be able to log in with your network credentials instead. We previously demonstrated how a single vulnerability result can be submitted to an issue tracking system such as Jira and Team Foundation server work items. Thunderscan also supports automatic submission of tickets based on an evaluated condition. This condition can take many forms. For example, a trigger can be set to submit a ticket based on a total count of vulnerabilities that were found in the scan, a total count of a certain risk of a vulnerability, as well as the vulnerability type. When you define a new trigger, you can choose to select it in the new scan configuration, and if the evaluated condition is reached, the ticket will be automatically submitted. Performing scans using the Thunderscan Sast IDE extension provides developers with close to a real-time information on the security posture of their code. They are able to track the entire user input flow from the source of the input to the sync function that caused the vulnerability, supported by code line highlighting in the IDE editors. By following mitigation recommendations provided by Thunderscan, they can fix the vulnerability and get a quick feedback on the effectiveness of the fix by rescanning the application. Thunderscan currently supports IntelliJ, Visual Studio, and Eclipse developing environments. For the next demonstration, we will use Visual Studio IDE. As the Thunderscan is already installed in this Visual Studio instance, we can review the configuration and parameters for initiating a scan on the current project. The configuration required for running scans is quite simple. As the extension is working directly with the Thunderscan API, we need to configure credentials required to access it, as well as the URL where it can be accessed. By clicking on the New Scan button, we can start the configuration for the scan against this project. As you can see, the extension recognizes the programming language of the project, for which the analysis will be performed. Here we have all the vulnerability types supported for that language. Any of the vulnerability types can be excluded from the scan. We can also see tracked input variables, which of course take the user input from some source, be it the HTTP request, file contents, command line parameters, etc. The miscellaneous settings such as scanning depth in terms of function calls and variable copying can be configured here, as well as any custom filters or custom vulnerability rules that we've seen in the Web UI demonstration. To start the scan against this project, we can simply click Start. The project is archived and uploaded to the Thunderscan API. As the scan is started, we will start receiving results from the scan. The scan is now finished. We can review the results and any source code highlighting will immediately be shown in the IDE editor. When reviewing the call stack of the vulnerability, we can track the user input starting from the initial variable where it was entered, all the way to the variable that was passed on to the sync function that caused thus the SQL injection vulnerability in this case. Now, let's load a simpler project as a use case for supporting the user during the development process. We created a demo ASP.NET application with a simple form that takes the user's name as input. Upon submitting the form, the application will say hello to that name, as we can see in the code behind that logic. Now, let's scan this project with ThunderScan. As the ThunderScan extension is already up, we can simply click Start. As you can see, ThunderScan discovered a cross-site scripting vulnerability caused by writing unsanitized user input to the response. If we review the mitigation recommendations, we can see that in order to mitigate the vulnerability, the input should be HTML escaped or encoded. Let's see what happens when we add a sanitization function around that input variable. ThunderScan detects the input filtering function and no longer reports a vulnerability. Going back to our application security flow in CI/CD, as we covered pre-commit checks, you can see how the API-enabled ThunderScan Sast would fit into other stages. With incremental scanning on commits, ThunderScan could be utilized to scan only the changes made to the code or perform a full scan during the build phase. In the upcoming webinars, we will talk about how ThunderScan is integrated into various build systems such as Jenkins, Azure DevOps, Atlassian Bamboo, JetBrains TeamCity, and others.